This is the demo for College Algebra, Lesson 24. When finding zeros of a polynomial function, what kind of numbers can I get? Well, here's a polynomial written in completely factored form where all the factors are linear. So I've got a leading coefficient of 1, and then I have x plus 3, 2x minus 1, x plus root 2, x minus root 2, x minus 5i, and x plus 5i. So I want to find all the zeros of this polynomial and then classify them as real or imaginary. And then if it's real, rational or irrational. And if it's imaginary or pure imaginary. Okay, so my zeros, I take each factor and set it equal to 0. So I would set x plus 3 equal to 0. And x plus 3 is a factor twice, which means I'm going to get x equals negative 3 as a 0 twice. So negative 3 is a 0, and maybe I'll just put a little note here that this has multiplicity 2, because the factor shows up twice, x plus 3. And we'll find all the zeros, and then we'll classify them after. So my next factor would be 2x minus 1 equals 0, and when I solve that, I get x equals 1/2. And then I have x plus root 2 equals 0. Solve that for x, and I get negative root 2. And then x minus root 2 equals 0. And when I solve that, I get x equals positive root 2. X minus 5i equals 0. Solve for x, and I get 5i. And x plus 5i equals 0. Solve for x, and we get negative 5i. Okay, so now I have all my zeros, and I'm going to use this chart to classify them. So negative 3, let's see, negative 3 is a real number. Looks like a plus 0i, and it is, in fact, an integer. Okay, so it's a negative, positive or negative whole number. It's not a whole number or a counting number because those don't include negatives. So this is a real number, and it's an integer. This is real. And they just asked me to, if it's real, tell me if it's rational or irrational. So the integers are within the rationals, so this is real, rational. 1/2, that's also real. There's no i's in it, so it's real. And it's also rational. It can be written as a fraction. Negative root 2, that's a real number because there are no i's, but it is an irrational number. Root 2 is listed as an example there. So negative root 2 and root 2, those are both irrational. Real but irrational. Okay, and then 5i and negative 5i, those are imaginary. And are they pure imaginary? Yes, because it's just bi. There's no a term. It's not like 2 plus 5i, it's just 5i. So they are pure imaginary. Okay, what is the degree of this polynomial? Well, once you have a polynomial in completely factored form, the number of zeros and the number of linear factors all add up to the degree. So I'm going to count the linear factors. I've got 1, 2, 3, 4, 5, 6, 7. 7 linear factors, so that means it's a degree 7 polynomial. And that's how many zeros I have, 2, if you count the multiplicity of 2 here. So this negative 3 is a 0 twice, so we do 1, 2, 3, 4, 5, 6, 7 zeros. And how would we begin to write f of x in standard polynomial form? We would multiply all of these factors together, and we could start with the x minus 5i, x plus 5i. We FOIL, and we get x squared for my firsts, plus 5ix for my outers. My inners give me minus 5ix, and then the last is minus 25i squared. The inner and the outer terms cancel. One's positive, one's negative. This becomes x squared plus 25. because the I squared is really -1. Number 2, consider the function f of x equals 2x cubed plus 2x squared minus 10x minus 4. We're going to find the exact values of all the zeros of this polynomial and then write it in completely factored form. And completely factored form always looks like a leading coefficient and then x minus a 0, 1, x minus 0, 2, x minus 0, 3. And I know that there are going to be 3 linear factors with 3 zeros because this is a third degree polynomial. So I use my graphing utility, either GeoGebra or a graphing calculator, to find one nice integer valued 0. So it looks like I have, that one does not go through a nice tick mark, that one does not go through a nice tick mark, but that one goes right through 2. Same thing over here. You can see that this point on the graph goes through 2, 0. So we have 1, 0 at x equals 2, which means I know a 0, then I know a factor. If x equals 2 is a 0, x minus 2 is a factor. So I'm going to go ahead and plug one of them in. So I have a times x minus 2, and then I don't know the other two still. I'll leave them as x minus something and x minus something else, trying to figure out what those things are. But I could use polynomial division to find another factor of the polynomial. What degree will it have? 2, right? Because I'm going to divide x minus 2, my known factor, into a cubic, 2x cubed plus 2x squared minus 10x minus 4. And in the very first step, you ask yourself, x times what gives you 2x cubed? And the answer is 2x squared. So I'm going to have a degree 2 polynomial as the quotient. All right, so 2x squared times x minus 2, that's going to give me 2x cubed minus 4x squared, and I subtract. Those go away. 2x squared minus negative 4x squared is 6x squared. Bring down the minus 10x. X times what gives you 6x squared? 6x. And multiply 6x times x is 6x squared. 6x times negative 2 is negative 12x. Subtract. I'm running out of room. The 6x squareds cancel. Negative 10x minus negative 12x is 2x. So I'm going to try to move this over here. So I have 2x. Bring down the minus 4. So here was a 2x. Bring down this minus 4. I've got this. And then you say x times what gives you 2x? It's plus 2. And then multiply 2 times the x minus 2, and you get 2 times x is 2x. 2 times negative 2 is minus 4. We subtract, and the remainder is 0. So this is my other factor, 2x squared plus 6x plus 2. So now I can write f of x as a product of factors, x minus 2, which was the divisor, times the quotient 2x squared plus 6x plus 2. Or x minus 2 times 2, I'm going to factor out a 2 because every term in this factor has a 2 in it, so pull out a 2. So I'm going to have x squared plus 3x plus 1. So remember our goal from part A is to write this in completely factored form. It wants to be x minus 2 times x minus something times x minus something. So this quadratic is not quite in that form, but I did find the leading coefficient a, should be a 2. So I want to set the function, now written as the product of factors, equal to 0, and solve for x. All right, so f of x, which is my original function, is 2x cubed plus 2x squared minus 10x minus 4. And I want to set this equal to 0 and solve it. I can now factor it a bunch. So I have 2 times x minus 2 times x squared plus 3x plus 1 equals 0. And now I'm going to set each factor equal to 0 and solve it separately. So either x minus 2 equals 0, which means x equals 2, and I actually already knew this one from the graph. I started with that. But now I'm going to set this other factor, x squared plus 3x plus 1 equal to 0. That doesn't factor easily, so I'm going to use the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So that comes out to negative 3 plus or minus root 5 all over 2. So now I have all 3 zeros. This one I got from the graph, and now I have 2 more. I knew there were going to be 3 zeros total because this is a degree 3 polynomial. So now I have all the zeros. So now that we know all the zeros, we can write all the factors. So just a reminder, the zeros were 2 and negative 3 plus or minus root 5 over 2. So now that I know the zeros, I can write the completely factored form. So it's going to be 2 times x minus 2 times x minus one of my zeros, negative 3 plus root 5 over 2. And then my other 0 is going to be put into the next factor, x minus negative 3 minus root 5 over 2. So what is the degree of the polynomial? 3. How many linear factors does it have? 3. How many zeros does it have? 3. Conclusions about polynomial functions. If a polynomial function is of degree n, if you count multiple roots separately, the equation has exactly n zeros, some complex, some real, and some non-real. And then an nth degree polynomial can be expressed as the product of non-zero constant and n linear factors, where each linear factor is of the form x minus one of the zeros. If a plus bi is a zero of the polynomial function with real coefficients, then the imaginary number a minus bi is also a zero. So imaginary roots, if they exist, occur in conjugate pairs, and the same is true of irrational zeros. If 1 plus root 2 is a 0, so is 1 minus root 2. That happened up here, right? Negative 3 plus root 5 over 2 and negative 3 minus root 5 over 2. We had the conjugate pair. Okay, question 4. Find a third degree polynomial f of x with real coefficients that has negative 3 and I as zeros and a leading coefficient of 1. Okay, so if it's third degree, which was given, then I know my function is going to look like this. It's going to be a, and then I'm going to have 3 linear factors, x minus a 0, x minus another 0, and x minus the third 0. So they've given me negative 3 is a 0, so I can fill some things in here. Negative 3 is a 0, I is a 0, and if I is a 0, according to this summary, negative I is also a 0. Okay, so I'm going to also put minus I as one of my zeros. And they told me that A is 1. So I can put a 1 there. All right, and then I'm just going to simplify this a little bit because they said I can leave my answer in factored form. So this is going to be x plus 3, x minus I, x plus I. Okay, just have a couple of notes about your homework in MyLab. The help options in MyLab for lessons 23 and 24 may show you something called synthetic division rather than the long division methods that we covered in class. You are not responsible for learning how to use synthetic division. If I would suggest using the long division methods covered in class, but if you are interested in synthetic division, you are welcome to use it if it makes sense to you. Also, the directions and help options in MyLab for homework 24 may say to use the rational zero theorem, Descartes' rule of signs, and possibly the graph of the polynomial function shown by a graphing utility as an aid. Okay, so I want you to do the third thing. We did not discuss the rational zero theorem or Descartes' rule of signs. So you are just going to ignore those, and you are going to go right to use the graph of the polynomial function that you will get using a graphing utility. You can use graphing calculator, Desmos, GeoGebra, whatever you're comfortable with. Just ignore the parts about the rational zero theorem and Descartes' rule of signs.